Hello, everybody. Welcome in. This is my talk called Doing Things Prometheus Can't Do with Prometheus. My name is Tim Simmons. I'm an engineer on the observability team at DigitalOcean. My team primarily runs centralized logging, metrics, and tracing infrastructure. You can follow me on Twitter, but I wouldn't recommend it because that is roughly the content that you will be there for. DigitalOcean is a cloud company that is focused on simplicity. We have everything you need to run the workloads that you want to run. My primary job at DO is caring for a Prometheus fleet that cares about metrics that kind of support the entire cloud. The first line in my CFP, kind of this along the title was clickbait to try and get my talk accepted and entice you to come to my talk. Nothing is like this cut and dried. You know, there's a lot of nuance in saying something like that, and like that might be like a cool tweet to do or whatever. But like that's nothing. I could be easily convinced that I'm totally wrong here. But I do kind of believe this. If you're willing to invest the time and energy in kind of understanding the tools and the outcomes that you're looking for, the old pillars that nobody is so fond of anymore, I think they're actually really, really good and good enough for you. The thing that is not good enough is us. And this shouldn't really come as a surprise to anybody, right? The problem with technology is always the people using it. You know, people will say things like, I don't have time to do good observability, or I don't have time to learn these complicated tools. But these are the tools that are giving you insight into how the thing that like pays your bills are performing. So if there's anything that is complicated that is actually worth learning and understanding, isn't it being able to do this? Like understanding your customer's experience. I think if you spend a lot of time making sure your customers are happy, your existing customers, I think the new ones will kind of figure themselves out. I think the hardest problem in the observability space is actually just convincing your boss or your leader that it is worth doing and worth doing well. And the way that you can reliably serve customers and do this is by intelligently instrumenting your software so you can see what's going on. But to produce those best outcomes, you have to absolutely understand what is possible so that you can make the best inputs. The goal here for us today is for you all to start thinking about observability like I do, at least for 30 minutes or so, because I'm right. And hopefully that is something that is generally useful as you kind of leave here and go and eat lunch or whatever. But I think it will also kind of help you understand where I'm coming from when I start explaining how we've done some more advanced things with Prometheus. And that's probably the real reason that you're here anyway. But while I was writing the talk and talking about those things, I kind of realized there's a common thread. And it was more about how I'm approaching those problems and how my team is approaching these problems. And I think that is something that is a lot more teachable in this kind of short format than trying to dive really deep technically on something and have you kind of keep that all in your brain or reference my slides later. But you can totally do that. Just in case someone in the audience doesn't know what Prometheus is or what metrics are, I want to do just a brief explanation. Metrics are real-time numeric measurements, and they usually are answering questions like how many things happened, or how much of a thing is happening right now, or how long something took. In code, we often increment or set metrics anytime something happens. So if you have a system that is doing things, every time something happens, you're going to set some sort of metric for it. Applications that are utilizing Prometheus serve a literal web page with metrics in plain text that you can go to and look at, and that is called exporting metrics, and I'm going to talk about that quite a bit. So this is really useful because you can actually see what Prometheus is then going to do is go in and gobble up these metrics, and you can see what Prometheus is ingesting. And so Prometheus will reach out, gobble up those metrics, and put them in a time series database that you can then go and query later. Looking at metrics and logs and traces, there are a couple of themes that kind of instantly emerge to me. There are a lot of promises floating around about people giving you observability for free, or being able to add it onto something at any time and get the kind of outcomes that you want. In my experience, when you just kind of rub observability on something like that, you're not really going to get the best outcome. These patterns and these tools need to be kind of thoroughly understood and then utilized thoughtfully. This needs to be something that is central to your software architecture and design. You should be designing from the beginning interactions that you can observe and test. And that way you can have clear signals about what is going on there and your performance. And that is the best thing you can do to have maintainable software. And to do that, I mean, I'm going to start to sound like a broken record, but you have to spend the time to understand the tool. You know, doing things like learning what to log and what not to log, more importantly, or what things you should be creating metrics for, and then learning different query languages for each of those things, finding the balance of what you should be tracing and what you should not, and when to sample, when to aggregate, how to visualize all that stuff. This all takes time and labor. And because of that time that it takes to kind of learn and understand this and do it well, people are starting to talk about going beyond. You know, we're going to correlate these signals. We're going to build simple unifying tools, some sort of overarching thing that is going to make this all easier. But you can't really do that because these things are all so different and also kind of nuanced. And it's hard to do any of that stuff well without that core understanding. And I don't want anybody to sleep on, you know, those old kind of fundamental pillar concepts and wait for the next big thing because it's going to be built on this same stuff. I hope I'm making sense here because what I'm trying to say is that none of this is easy. You heard it in the keynote yesterday. You know, it's not easy and we're trying to make it easier. But even with that top quality stuff that you're going to get for free, you still have to understand how to transform that into a good result. I want us here today in a headspace where we are treating these tools like the critical infrastructure that they are, not as something that comes later. Because that is the way that we effectively maintain software and keep customers happy and keep dollars flowing. Getting really good at this is worth the investment, and it's really fun. So Prometheus. The reason you probably added this talk to your schedule is because I was going to talk about doing fancy stuff with Prometheus, and I will. But you need to be ready for a little bit of a letdown, because the more I thought about this, the more I realized there isn't special sauce. These are kind of logical thought processes that result from being really familiar with this tool. And these are hard problems to solve, and the tools can't be good at everything. That's why there's so many tools. So you kind of need to get good, or at least fluent, in all of them. But you know, even just one will get you kind of a really good, you know, at least get you most of the way there. Having said that, though, Prometheus is actually just about as versatile a piece of software as I have ever used. Knowing the supposed limitations that people throw out, I am constantly surprised with how well it stands up to just utter and complete punishment that we routinely inflict upon it. And that's why I'm here, because I think people are glossing over how great that we kind of have this already. So Prometheus is intentionally not a distributed system. It is beautiful in its simplicity in that way. It's very easy to kind of set up and explore and start to understand what the value that you're going to get out of it is in the future. As long as resource usage is kept in check, the network is up, and the things that are exporting those metrics are up, you're basically good to go. Sometimes, though, the network does break, or queries make Prometheus sad, or exporters go down. So people want to start talking about doing high availability Prometheus. This is the kind of thing that can happen. So I have an instance here that was running perfectly well for a while. It's short there, but you know, this thing is running for weeks at pretty constant resource utilization. Then all of a sudden, it doubles, triples in resource usage because somebody queried it big bad. But if you've got headroom, this is fine. But if you run out of CPU or you run out of memory to process this query, then you can slow an instance down to the point where it becomes unresponsive. And this is kind of the only thing that I see kind of routinely, you know, operationally in running Prometheus for people is that sometimes, you know, people make it sad. So what happens when you do that is that you might end up with a gap in metrics when you're querying later, because you will have put that server in a situation where it can't go out and reach for metrics anymore. It also means, you know, a gap in a graph, if it's a normal day, is maybe not such a big deal. But when it is not scraping metrics like that, it is also not evaluating alerts. So if you do have something terrible happen in that space, not only will you not be able to see it, you won't get alerted for it. And that is actually pretty bad. The way that folks generally work around this is by deploying replicas of Prometheus that scrape the same things and evaluate the same alerts. Ideally, they do this in kind of separate geographical locations, you know, to kind of air gap yourself from a basic network failure. This means that you need a way to switch between querying multiple instances of Prometheus at one time if one of them has an issue. And a proxy is a really good answer here. So putting that in front of your HA replicas, and then, you know, you can switch if one of them is having problems. You can run health checks on the graph endpoint in Prometheus, which is just a regular page that you would use to go and dork around in the UI. In my experience, that is a pretty good proxy for is the Prometheus up or not. As I'm reading this, I now realize there is a status API that you could probably also query, so maybe do that too. Ideally, you could manually fail over those instances in your group, so because maybe there's a network issue between Prometheus and the things that it is scraping, and you know about that because you got an alert from somewhere. But Prometheus is actually like, hey, I'm doing Gucci, man. Like, there's less metrics coming in, and I'm actually happier. But then you query and say, hey, where are all my metrics? If you've got a network segregated Prometheus somewhere that is not subject to that issue, you could go and poke your proxy and say, hey, actually, go look over here. We need to see what's going on. And then ideally, you would not rotate back to that other instance that has those holes until the other one has problems. So yeah, you would still have a hole in your metrics, but like if you rotate 7 days later, the only time you're going to see that hole is if you're actually looking that far back in time. You also get a few things for free with a proxy, like query logging, although Prometheus does do that now, but I've been using it for a very long time, and it has been very, very useful to see who's being naughty. And then potentially something like rate limiting too. So this isn't really high availability, right? Because there are situations where this could become unusable. But you're not really going to be able to tolerate a massive network failure in a system that uses the network to go out and reach out for metrics. So deal with it, I guess. But you can minimize those gaps, right? And hopefully you can be able to find them, find those metrics that you need somewhere if it's really important. And as bad as I made that sound, I've been running Prometheus, pretty large infrastructure for years, and there's only been a couple of cases that I can remember where I didn't actually have something that somebody needed due to either a network or a bunch of instances going down. There are options, though, if you are kind of wanting to go harder in that way. There are things like Thanos Query or PromXY, and these promise to fill those gaps in your metrics even if one of them goes down, and you can have just like one thing that you're querying. The way they do this is actually by fanning out queries. So if you have 4 instances that are scraping the exact same thing, 2 of them go down, this thing will actually query all 4, see that there's a gap in the first 2, and then fill it in by deduplicating data and giving you one solid graph. There are some risks here, though. So you will have decreased query performance, at least in a little bit, because there is CPU time spent once that proxy fans out, and then kind of coalesces those things together. You also can pay double the cost for latency of your query. So say you do a big fat query that returns like 40 megs of results. Maybe your network is slow, maybe it's not, whatever. That result will go from Prometheus to this proxy, do some work, correspondingly larger amount of work with the larger your data set is, and then send it back along to you. And if you're running queries that are like 15, 18, 20 seconds, you will kind of feel this a little bit more. The other risk is that if someone does a really big query or loads up a big fat killer dashboard over like 8 weeks or something, these queries will fan out to all of your Prometheus and DDoS all of them. And then you are creating that gap that you were trying to avoid in the first place because none of your replicas are up. There's also some increased operational overhead. This is another component to run, and because Prometheus is generally so easy to operate, this thing can actually be as hard to operate as Prometheus itself. But there are other benefits too. So you can get something like a global query view, so you're not changing data sources in Grafana or trying to figure out which Prometheus has the metrics that you're looking for, and that is pretty cool. Let's talk about cardinality for a second. This is a quick refresher because this is not something that is intuitive for people when they start using Prometheus, but it's probably the most important thing for you to know. Every unique permutation of label values in Prometheus creates a new time series. So you can see in that example below, I have 3 different time series because there are 3 different kind of combinations of potential metric label values. The official recommendation from Prometheus is that any individual query should match hundreds and not thousands of time series. So you see I've done a query that kind of matches 3 here, but you can maybe think about how if I was doing a sum across HTTP requests across my entire application, how this could easily find hundreds or thousands of time series. You can work out a query at a single point in time to figure out kind of how dangerous it's going to be. So you can see like how many time series are going to be returned, how long did your query take. And you should do that before you go and graph something, because the way that a graph works is it evaluates your individual query at many, many, many points in time and then connects them all together. So if your query takes 10 seconds when you evaluate it for the last 5 minutes, it's not going to work too great if you're doing it over a week. So basically what you should do when you're creating metrics is to try and avoid labels that have unbounded potential values. And then watch the number of total labels that you put on a metric. Because you've got a big metric already, and then you add another label that just has 10 values, you have just 10x the cardinality of that metric. So if you're following, what I basically just told you to do is not create metrics when you're creating metrics. In my experience running Prometheus for people, generally any query that is worth doing touches thousands of time series. Some of them even hundreds of thousands. So we've got to find a way to work with this. Luckily, if you're querying under about 2,000 time series, you're totally fine. And then if you even go up to like 10,000 or so, I'm not even worried about you. Going beyond that, though, we might have to do some work. If you're going to do those higher cardinality queries, there are some things you can do operationally to Prometheus to help limit the worst of the pain. So you need to have significant amount of memory and CPU headroom while Prometheus is running. A queried instance is a completely different animal, like I showed you earlier. You can set a limit on how many samples. I'm sorry, I should give you a guideline on headroom. I usually do 50%. It still dies sometimes, so it's just money, right? So just keep on picking it up, or just run it in Kubernetes and let it eat your entire cluster, whatever. You can set a limit on how many samples a single query can load into memory. So samples means individual values inside of the individual time series. So if you're evaluating a query that touches 1,000 time series over 2 weeks, it's going to have to evaluate that query potentially thousands of times. So then you are multiplying that number of time series by a big number. I usually set this to like 50 million. If somebody's doing something that is more than 50 million, I don't want them to do it. And Prometheus generally will kind of calculate the number of samples that it's going to load. It takes like 5 seconds or so, and then go, hold on, Jack, are you sure? And I usually say no. But I have been known on occasion to bump up this limit for somebody who wants to do more. You can also set the limit on maximum concurrent queries that are being done in Prometheus. You should absolutely do this. I usually set it to 1 per CPU core on the instance. The reason for this is if you are doing 20 queries at a single point in time on a box that has 8 cores, it is going to have to do a lot of context switching, and it's not going to go well. It's better to wait the quarter of a second or whatever for another query to finish and then execute your new one, rather than just kind of doing them all at once. What usually happens when you do something like this without this limit is you're loading a big dashboard with 100 queries on it, and they will just all come back failing. And then if you set this limit, then they can all just roughly come in maybe 2 seconds later. You should also shard metrics or federate or both. So at DO, we are a cloud with lots of regions, and there are times where people want to answer questions about the entire cloud. Unfortunately, it's a big cloud, so answering that question out of Prometheus would require a query across a giant global set of data. So I shard this stuff regionally. This means that people are a little bit sad at first because they're like, well, now I have to do my query for every region. But you still get your answer, and that's better than no answer at all. And honestly, it's not that hard to stitch it all together. If you really, really care, isn't it worth doing a little bit of work? I don't know. That's how I feel about it. But you can also federate. So if you could do regional sharding and then create kind of a layered cake of Prometheus where you are aggregating something at a regional level and then only putting that stuff in the next tier up. So then you could do that global query. Again, just a little bit more, kind of labor that you have to do, but hey, you're answering your question. When you start going really hard with queries, you need to be kind of careful. Be careful with your aggregation, so scope down to only the things that you actually care about. Increase your step size of your query so that you have, at first, the lowest resolution that you can stand, and then the same thing with a smaller kind of time window and then scale up. So if you're going to do some sort of big query over a week, maybe start with an hour at 5-minute resolution, and then kind of work your way up instead of just punching it right in the mouth with the big query. There's another thing that you can do is you should be able to understand kind of your query pattern and the questions that you're going to be trying to answer with these metrics, and then create the metrics and query to match. So this is a lot of stuff to care about. But again, you're doing something that's really hard, so you have to care a little bit. It's like you're supporting customers. I don't know, like what is more important? So doing these kind of things, I routinely help folks query metrics that have hundreds of thousands of time series. And if you listen to vendors and things, this is something that you absolutely cannot do with Prometheus, and I'm here to tell you that they're lying. It's just a little bit harder than, it's just a little bit hard, but it's fun. I'd like to give you an example of crafting metrics that match desired outcomes, because this is something that I don't think people are doing enough. Say you've got some sort of web service that has potentially thousands of endpoints that you might care about latency for. You want to know per endpoint latency, you want to know latency per API version, and then you want to know global latency, just one single number. You should create a separate metric for each one of those questions. So you will have one metric that has a label value for every endpoint in your app. And then if you tried to do a global latency calculation on that, everything would fall apart. That's fine, because now you have a separate metric for global latency that is tiny, 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 and it comes back instantly. And that's really good. And then another one for some sort of group that you care about. This does create more metrics up front, and it does increase your regular resource usage a little bit. But you're not going to blow anything out at query time, and then you can actually answer all the questions that you want. So you have to maintain a bit of cognitive load. You got to know what to query for what. But I think it's a fair trade-off to being able to actually answer your questions. And like I said, spend a little time, understand your tools, because they're really important. Long-term storage is something that people routinely ask for in Prometheus. Prometheus pretty recently released disk-backed retention. So basically, if you provision a big old disk on your Prometheus instance, you can tell it to just fill up the entire disk with metrics and start deleting them when it runs out of disk space. You can do this with a block storage volume as well. If you keep the maximum block size, that is the size that Prometheus, size in time where Prometheus will compact your metrics down to, if you keep that relatively low, like 3 to 7 days, when you run out of disk space and Prometheus needs to delete metrics, it will delete by block. So if you let this compact down to like 4 weeks or something, and then you run out of disk space, you're not deleting 4 weeks of disk space or metrics and then freeing up like half of your disk. You can kill little tiny bits at a time. This has a little bit more overhead when you start querying, but in my experience, it's not so bad. I turned this on in our infrastructure about 250 days ago, so my experience doing really long-term queries is somewhat limited, but doing kind of some of the stuff I talked about before, I've had like perfect, easy success doing kind of long-term queries. And 250 days or a year or 2 years is a lot more than people need. Even just like 4 to 8 weeks is often enough for every question. There are new solutions in this space, though. Things like Thanos, M3, and Cortex. They offer long-term storage as well as a lot of other potential benefits. So that like global query view I was talking about earlier, multi-tenancy, downsampling, compaction, pushing metrics, natively scaling horizontally. These are solving really big problems compared to just vanilla Prometheus, and they come with a correspondingly large amount of operational overhead. So the cost to run any of these things is much, much more than Prometheus, and it needs to be staffed appropriately if you're going to do something like this. My opinion is that if you're looking at something like this just for long-term storage, you should think about whether you really need to keep that data long-term in the first place. In my experience, it's a thing people think they want but almost never use. And the problem is that, especially if you're considering a big solution like one of these big boys, the expense in operations and money is a lot higher for the relative utility that you're actually getting. My recommendation for long-term storage is to throw that big fat disk of Prometheus and just let it go hog wild. If that doesn't work, you could think about setting up a long-term Prometheus instance and federating only that kind of aggregated long-term trending data that you really want to keep. And if you do that and keep that data relatively small, even just like 4 gigs of RAM and a 100 gig disk, you're going to keep that stuff for years. But I say it again, you have to do that labor, you have to think about the solution that you want, and kind of care about your outcomes. And then you've got to campaign for the time to do that. And ironically, it might even be easier to convince some leaders that you should stand up a large, new, cool system because it has kind of that cloud native cloud. But if you don't need all of that, you really shouldn't because it's going to be very expensive. Once people start getting value out of metrics, a common idea that folks have is wanting to do machine learning or anomaly detection on it. And I'm sure this is possible. I've heard a lot of amazing stories about what machine learning can do. I've personally never seen even an outcome, good or bad. this seems harder than it looks, and it looks pretty freaking hard to me. I'd like to give you a couple of tips, though, so that you can do some basic kind of anomaly screening predictive analysis in Prometheus, and then you can tell your leaders you're doing machine learning and get yourself a big raise. So this is a good example from the Prometheus blog a while ago. So you've got a handful of instances of like a web application that are serving, kind of similar requests. You can examine the group of latency metrics to find outlier instances that might be running kind of slowly. You can do this by checking out request durations average that are sticking out by 2 standard deviations. And then additionally, you can mitigate any false positives if your data is really closely clustered together by checking that the value must also be 20% higher than average. So this is an absolute unit of a query, but you can break it down into its component pieces fairly easily to kind of understand it. Spend an hour, understand the tool, you get it. Another one I like to do is trying to find spikes and odd events. So if you got something that is normally very, very consistent, and you can examine some sort of recent amount of time, like 5 minutes or 10 minutes, compared to the last 24 hours or so, you can see if you've got some sort of change. This is a great kind of first alert if you were, you're kind of starting on your journey toward, doing this kind of thing, and you just want to know when something happened. This is a good thing to kind of know what's going on there. The only other thing that is better than catching a problem right away, though, is catching it before it even happens. The predict linear function in Prometheus uses, or it predicts a future value based on a backward-looking linear regression. So the canonical example is alerting you're going to run out of disk space before you do. Imagine how useful that would be on like a database, for example. This is great, though, whenever you have some sort of capacity or saturation metric. It's a little bit similar to the last example because usually something has started happening that has changed your future in a way that is undesirable. But it's good for longer term stuff like a disk filling up really slowly or like a TLS certificate expiring as well. You can write an application that exposes metrics for just about anything. So in fact, most of the ones that you would want to write probably already exist out there. At DigitalOcean, we've written exporters to quantify capacity in our fleet in various ways, look at our events pipeline, and look at individual customer resources. And these are all things that are incredibly custom, right? Only useful to us. A lot of times an exporter is a really good replacement for some sort of older monitoring tool that goes and like tickles a bespoke bash script or command or something like that. Because you can standardize all that stuff into one Prometheus place, and you get a few things for free, and having all of your stuff in one place and able to kind of query and make dashboards off of and do alerts on is really, really great. There's one real gotcha that I've seen bite people a lot when writing exporters for the first time that I want to try and warn you about. This is in the Go library, and it happens to you when you are kind of writing your first exporter and like reading the documentation and doing it kind of the naive way. Basically what happens is you will create a new time series with some combination of labels, and you will choose a label value that represents something ephemeral. So say you're exporting metrics about a queue name that is only there for 5 minutes or so. What will happen using this kind of naive way that is very, very easy to use in the client is that metric will then be present in the metrics endpoint that your application exposes as long as the application is up, so until it gets restarted. So then you'll be querying your stuff in Prometheus later or get an alert for something, some queue name or whatever. You're like, whoa, 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 that shouldn't be like that. That shouldn't be there. And then you go and look and it won't be there. You're like, well, why are my metrics wrong? The workaround is to use a pattern called const metrics in the Go library. This pattern essentially gathers the metrics at scrape time. So instead of kind of just bopping a little function or something inside your code, you can kind of either just leave it to entirely a thing that happens in scrape time if it's really fast, or you can keep the kind of information that you want to be exporting metrics about in some sort of other abstraction in memory in your code, and then build them at the time that the scrape happens. You should always be doing this when the source of truth for the metrics that you're exporting is not your code itself. So if you're doing something like doing a database query and then kind of generating metrics from that, or poking around in some sort of stat socket, or writing an exporter for some sort of large system that you're kind of just exporting some kind of health stuff about, this is what you should do. I don't expect you to remember that. What I would hope is that you kind of remember this moment, and then maybe when you're doing this someday, you can like tweet at me or go read, you'll remember const metrics, and you can go like control F that in the docs and kind of see what I'm talking about. Prometheus and Alert Manager kind of go together like PB and J. So Alert Manager groups many, many alerts from Prometheus and sends one single notification. I like creating team or service-specific alerting levels so that like all of my team's debug alerts go to one Slack channel, and then all my team's critical alerts will go to PagerDuty and a Slack channel, something like that. The configuration for Alert Manager is very, very powerful, but it's a bit of a bear to write, especially when you're doing something like global for an entire kind of organization. You see up on the right, and that tweet is actually my Alert Manager routing tree, and you wouldn't even know it's a tree because there are so many lines on it. Those are all the places that alerts could possibly go. There's a lot of good literature out there about what you should alert on. I don't know if I said this. When you are creating kind of that Alert Manager config, make an abstraction and generate that config. So like I don't really have to care if my Alert Manager routing tree looks like a broken record because I generate that config and it's fine. An Alert Manager can totally handle it. Except in the UI, it does crash Chrome, but that's fine. There's some good literature out there about what should be alerted on. I'm not going to like dive deep here because that could be a whole talk, but alerts should prompt action and then have all the context attached to the alert necessary to perform that action. So write a playbook attached to your alert. Also, if you're doing Slack alerts, use the tool that Julius wrote to create beautiful Slack alerts so that you just don't get like viscerally angry whenever you see them. The pinnacle of mindful observability is implementing SLOs. So you should read the chapter in the SRE book, or it's really like the entire SRE book. But essentially the idea is that you should be defining the type of performance experience that your users can expect, measure it, and then take action to maintain that level of service. This is the most important thing to measure, right? So talking about being outcomes oriented, this is the outcome for your customers. This is the thing that you should be measuring. But quantifying it is actually really, really hard. But it's an essential exercise. And the first few times you do it, it might actually require some work. You might even need to change the architecture of your application to be able to measure that thing in the right place. But once you've measured it, you can then set an objective. So this is often like some number of 9s. And then you can give yourself an error budget. So that would be like the amount of time that you're allowed to violate your SLO. You can use that then as a simple, this one simple thing as a factor in any decision making that you might have to do. So if you have a service that's consistently violating its SLO, and as an organization you've decided that SLOs are important, you can then make the leap that you should not be doing any work that is not in aid of fixing that problem. This is a great way to push back on decision makers that might be trying to push new work on you or new features or something, because it's really hard to argue against not achieving your SLO. Prometheus can help you set this kind of system up, and I want to show you briefly how to do that. So this is the 99th percentile query latency in my Prometheus infrastructure over 24 hours measured hourly. Say I wanted to define availability to be that 99% of my requests complete in under a second. I can express that in a Prometheus query as a binary 1 or 0. Did this happen or did this not happen for a time period using this less than Boolean operator in Prometheus. So you can see on the previous graph, there was one kind of hour where my latency, my 99th percentile latency was over a second. So now in this graph, it's a 0. So I failed for that hour. Then you can use a Prometheus SubQuery, which are awesome, to find that exact same data on that graph, which was generated by evaluating one query at 24 points in time and drawing all the lines together. You can get all that data in one query so that you can then use it in another query layer. You see all those 1s and 0s there. We can then take the average over time of that data set, and because it's expressed in those 1s or 0s, we can calculate a percentage of time that we met our SLO. So if you're doing a time-based SLO, this is a very easy way to do that. So you can see that we actually had an availability of 95.8% over those 24 hours. So if we wanted 99% availability, then we'd be in violation. For simplicity here, I evaluated the queries every hour. In real life, you'd probably do it every few minutes, or if you were doing like 7 days, you might go hourly or something like that. And intervals actually do matter, because when I dropped it from evaluating to every hour to every minute, my 95% pass rate dropped to 71. So a little trick out there for you people trying to hack your SLO. But like, don't do that, actually, because you're only hurting yourself. A couple of more PromQL tricks for you. In this example, I'm not using a histogram quantile to estimate my 99th percentile latency. I set my SLO at 1 second, and I am actually counting the requests that were less than or equal to a second, and then my total number of requests. So I can get a more exact number of requests that actually took less than a second because I'm using that histogram bucket. Another problem that you might run into here is that if you don't have any requests for 5 minutes, you would be dividing by 0 here, which is not allowed in Prometheus, and it would break your entire query. So using this little trick with OR, you can sanitize that time where you had no requests as a 1 in your kind of binary 0 to 1 by using any metric that is always extant. And then we can use the same pattern as we did in the previous example. So we can calculate the percentage of time over the last week where latency was less than 1 second and feed that into an SLO. All right, everybody, we did it. Remember, doing observability well requires time and effort, but your reliability is maybe the only thing that is important enough to justify that kind of investment. You need to do it anyway if you're going to want the best, if you want the best outcomes, because low effort inputs are not enough for your customers. You should pick some tools and get really good at using them. I'd recommend Prometheus because it's just excellent software. And that's it. If you have questions, you can come up and ask me afterwards over here or outside or something, but I want to let you go to lunch, and I cannot take the risk of any of you embarrassing me in front of this entire room. So thanks for coming. I appreciate your time.